this lesson, we're going to take a look at some special kinds of matrices that you should expect to see throughout our course. The first special kind of matrix we're going to work with is called a row matrix. And essentially a row matrix is any matrix that we might see that has only one row. So for example, I could say that matrix capital R looks like this, 1, 3, 0. It only has one row, so we call this a row matrix. A row matrix is always 1 by n. One row and as many columns as we need. In this case, R is 1 by 3. The second kind of special matrix we might see is called a column matrix, and similar to row matrix, only in this case we have only one column. So if I were to write 1, 3, 0 going downwards, now we have only one column, and capital C here is a column matrix. And column matrices are of the form m by 1. In this case, C is 3 by 1. We can have as many rows as we need, but we only have one column. The next special kind of matrix we're going to see quite a lot is called a square matrix. And as you may guess by the name, it's any matrix that has the same number of rows and columns. Sometimes in our future lessons, instead of saying that a matrix is square, we'll say something like an n by n matrix. And in fact, in the coming chapters, when we start working with inverses and determinants, we're primarily going to be focused on square matrices because they have very nice properties that we can use. So let's give a couple examples of square matrices. So here is matrix A. Let's maybe make this a 2 by 2 matrix. So 1, minus 1, 2, and 5. I'm just picking numbers here. All I have to do is ensure that we have the same number of rows as columns. So here we have 2 rows, 2 columns. So we have a square matrix of size 2 by 2. And of course we can have larger square matrices. So maybe I'll create one that is 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's matrix B. It has 3 rows and 3 columns. So this is a square matrix of size 3 by 3. Now square matrices have something that we're going to be using every once in a while, and that's called a main diagonal. And the main diagonal consists of all of the entries where I is equal to j. So for example, this is the 1, 1 entry. This is the 2, 2 entry. So it's these values here that make up the main diagonal of matrix A. Similarly, for matrix B, this is the 1, 1 entry, 2, 2 entry, and 3, 3 entry. So it's these 3 numbers here, 1, 5, and 9, that make up the main diagonal of matrix B. For the purposes of our course, we're only going to consider square matrices as having a main diagonal. Next up, we have some special kinds of square matrices called triangular matrices. An upper triangular matrix is a square matrix where all of the entries below the main diagonal are equal to 0. So for example, I could draw a 3 by 3 upper triangular matrix. Like this. And recall that this is the main diagonal of our 3 by 3 matrix. And what we are looking for is we're looking for all of the entries below the main diagonal equal to 0. So this matrix U is upper triangular because we have a triangle of zeros below the main diagonal. And of course we have a counterpart to our upper triangular matrices, and these are called lower triangular matrices. These square matrices contain zeros above the main diagonal. So for example, let's create a 4 by 4 lower triangular matrix. So maybe we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. As long as I have zeros above the main diagonal, this is going to be what we call a lower triangular matrix. So for a 4 by 4, this is going to be our main diagonal. And notice that we have a triangle of zeros above our main diagonal. And that's what makes this a lower triangular matrix. Now notice down here that we have the number 0 on the main diagonal, and that's okay. All we really care about is having a triangle of zeros above the main diagonal. And last but not least, this leads us to our final special kind of matrix that we're going to talk about in this lesson, and that is a diagonal matrix. These special square matrices are both upper and lower triangular at the same time. So, for example, we could create a 3 by 3 diagonal matrix as follows. So I put my triangle of zeros at the bottom so that this is upper triangular. And we put a triangle of zeros at the top so it's also lower triangular. What do you notice? So the only numbers that are allowed to be non-zero values are on the main diagonal. Even if there is a 0 on the main diagonal, that's okay because it will still be both upper and lower triangular. But the key here is that all of the values off of the main diagonal have to be 0. Now to end off the video, I absolutely have to remind you to remember that triangular matrices end up being the exact opposite of what you think they are going to be. So upper triangular means zeros are below the main diagonal, and lower triangular means zeros are above the main diagonal. I don't know who labeled these, but they did an awful job. So, like I said, just remember that it's opposite of what you want to think. Now, I also want to leave you with an open-ended question, and that is, what is the importance of these kinds of matrices? I'm going to leave that for you to do a little bit of research. If you do take Linear Algebra 2 with me or with one of the instructors in the future, you're going to see the importance of diagonal matrices. All right, my little epsilons, stay positive.